Friends, welcome to my channel. Welcome to Medical Concepts in Brief. So, today we're going to just have a quick look in ventricular pressure loop. So, you all would have seen something like this on a pressure volume curve, but or let's draw like again. So, it's like this. Okay, so all of you have seen this, but what exactly do you mean by all these curves? So we'll take a quick look. So in this, on the left and the right, so on the left we have pressure, so this is in millimeters of mercury, and on the right we have volume, this is in ml. Okay, so this is basically the graph which depicts the function of the left ventricle, and that is why it is known as the left ventricular pressure volume loop. So we'll start, let's just give these dots name A, then you have B, you have C, and then you have D. So these are all the different points. So when we start right at, let's say at the point, we can start anywhere. So this is what we're talking about, what are the different phases of a left ventricle. So starting with a point where the ventricle starts contracting. So we all know the left ventricle, before releasing blood, it starts without any valves opening. At that particular point there is no valve which is open. So in this point, so the ventricle starts contracting, but it is not oozing out any blood anywhere. So that means in that particular moment the volume of the left ventricle will remain same. So that is why this line is perpendicular. So you can see the volume here, it coincides at the same point. That means throughout this phase you can say this DC. So you can say this DC, this is a phase of isovolumetric this is a phase of isovolumetric contraction. That means iso means same, volumetric means at the same volume, and the ventricle is contracting. Now this particular point is the point where the pressure becomes too much, that here the aortic valve opens. So now that means all the blood which is there in the left ventricle is going to transmit it through the aorta. So what does that mean? That means the volume is going to suddenly go down. So you can see on the left, the curve goes from C to B. That means the volume as is depicted here. So volume goes from here to here, and at this particular point the pressure the pressure also slightly increases at this particular point. So C into B, if you say, is the point where the blood flows into the aorta. Then the ventricle will reach at the point at B where there is a certain amount of pressure, but the volume is significantly decreased. So at this particular point the pressure of the aorta becomes higher than the pressure in the ventricle. So this particular point, what happens, the aortic valve it closes. That means now all the blood has come out. So the aortic valve will close it. Now that ventricle will reach at this particular point B, and B to A, you can see again we have a vertical line. That means at this particular point the ventricles now starts relaxing so that it can contain another cycle of blood. So at this particular point the pressure starts dropping, and but the volume remains the same. So at a point when the ventricle reach A, at this particular point the pressure is very low. So the pressure above in the aorta, in the atrium, it increases to a point that now the mitral valve opens. So at this particular point the mitral valve will open. So you can see B to A, this B to A, this is a point of isovolumetric. Again we are using the same word isovolumetric, that means the same volume, but here the ventricle is not contracting, now the ventricle is relaxing. So this is isovolumetric relaxation. So at this particular point A, the mitral valve opens, and now the blood, all the blood which is there in the atrium, in the left atrium, is now starts oozing into the ventricle, and the pressure as well as the volume of the ventricle starts increasing. So this this A to D so this A to D is a point where the ventricular fills up with the blood. So this is a phase of ventricle filling. So you can see now it reaches to a point, this is the point D, where the pressure is low and the volume is high. So the ventricle is completely filled with blood. At this particular point the pressure in the ventricle becomes increased greater than the atrium. So at this particular point, that is D, the mitral wall will open, sorry, the mitral wall will close. Okay, so this is all about the left ventricular pressure volume loop. So I hope you now understand, and for it to for let's revise this again. So we'll just talk about only the points. So if we draw it again, so you can see on the left we have the pressure, on the right in the x-axis we have the volume, and this is the curve of the pressure volume. Let's draw it again. So we can see as at this particular point the mitral valve opens and the ventricle starts filling. That is the point, the ventricular filling. Then it when it completely fills, the mitral valve will close, and this, as it closes, now it will start contracting. So this is a phase of isovolumetric contraction, and when the pressure becomes high at this particular point, now the aortic valve opens up, and all the blood which is there in the ventricle starts going into the aorta. Then after that, this is a point, this is basically the point where all the blood which is there, it starts ejecting into the aorta. Then coming to this point, at this particular point when all the blood has ejected into the aorta, this particular point the aortic valve will close, and again at this particular point it starts filling. So this is this basically starts preparing the ventral starts preparing by going under osteovolumetric relaxation. There is no filling here, but it reaches to this point where the mitral valve will open, and all the blood will now start filling from the atrium to the aorta as soon as the mitral valve open. Okay, so that's all. Do subscribe to my channel. Thank you.